Okay, dear friends, dear colleagues, I would like to welcome you to this lecture. The title of my talk is the IGS Creation, Development and Achievements in the Early Years. The addendum early years is due to my age. Oh, it works. This report is based on many written documents, IGS annual reports, IGS workshops, many scientific papers, and what is more dangerous, on my personal memories. The history of many institutions and individuals are closely linked to the development of the IGS. And quite a few of these institutions and individuals are represented here in Bern, the individuals as veterans, I would say. It is a great honor for me to present this overview on behalf of all the veterans, and to show you what a veteran is. I put on my Congress suit of the 1990s. Only that the young people can say that I also was giving them some useful information. What is the IGS? The IGS is in the first place the outcome of the IGS Campaign Oversight Committee, which was active between 1991 and 1993, and the IGS 1992 Test Campaign. It is an official IAG, National Association of Geology Service, since 1994, based on a network equipped with GNSS receivers. And I would say today it is an interdisciplinary service providing geometry products and clock products and atmosphere products. The official operation started in 1994 as the International GPS Service for Geodesy and Geodynamics, which was then renamed as International GNSS Service in 2005. The essential steps of the transition were the IGEX 3 months GLONASS test campaign, the IGLOS test service between 2001, I would say, and 2005. Then there were the European Galileo, the Chinese Beidou, and the Japanese QCSS, and many other systems coming up. But they became an issue only after 2010. I think a very important step in the IGS is its understanding today as a multi-GNSS service. Multi-meaning more than 2 GNSS. It started really in 2012. The IGS is also based on a rapidly growing constellation, first of GPS satellites from 4 to 6 in 1982, and to about 24 in 1995. That were good times because you could observe only a few hours per day in a special location. Today it's more stress, you can and you do observe 24 hours a day. What was also very instrumental was the strong support from the US Department of Defense, the US Department of Commerce, who were organizing the International Symposia series on precise positioning with the GPS. What was as important as well was the rapid development of the Internet for data, IGS data collection, and the exchange of scientific results. The IAG, International Association of Geodesy, hosts long-lasting services with products easily accessible to the scientific community. I would like to remind you of the first IAG service, I hope I'm correct in that, the ILS, International Latitude Service, which was founded in 1899 and was then continued in the 1960s. So it was active for more than 60 years, and I think that would be the next goal for the IGS to reach the 60-year mark, just to beat these guys from the IRS. There was also very important was the preparatory work of people like Jerry Nader from the US National Geodetic Survey, the dedication of IHE and GPS leaders, and I'd like to mention in particular Ivan Müller, Georges Palmino from France, Chris Riper sitting also here, Bill Melbourne, and many others. I cannot be comprehensive here. Let me say a few words to Ivan Müller. Unfortunately, he passed away last year in 2023. I hope 2023 was last year. And I would like to read to you one sentence. The primary motivation in planning the IGS was the recognition in 1989 that the most demanding users of the GPS satellites, the geophysical community, were purchasing receivers in exceedingly large numbers and using them as black boxes, using software packages which they did not completely understand, maybe for relative positioning. I think it's quite a similar situation today. For many years, Ivan Müller was really the IGS veteran par excellence. And in the opening session of this symposium, I understood how he should be called today, because one of the speakers was a geologist. And now I have to read that. He should be addressed really as a guide fossil or leading fossil of the IGS. And I think he would like that. Guiding and leading people was one of his main goals. Of course, there were more scientific motivations, like for instance, the generation of precise ephemerales. IGS colleagues of the first and later generations, don't be afraid, I will not read all these names here. That would cost me all the time I have theoretically. But I would like to read the name of the founders: Jerry Nader, Bill Melbourne from JPL, Bernard Minster, geophysical person, Ivan Müller already mentioned, and Ruth Nealon, who organized many of these CASA campaigns for the JPL, and was then for years and years the head of the IGS Central Bureau. By the way, Ruth Nealon wanted to come here, but unfortunately that in the last moment she had to skip that trip due to health reasons. You see that it was already mentioned from these chairpersons, all but one is here. I think his excuse really was the long trip to Bern. He's really beneath this audience, but something like 12,000 kilometers on the river side. What was always very important for the IGS is the link to the IERS. You see here a few names, and let me mention that Suhair Al-Tamimi, my dear friend, is also here today. The timekeepers, Dennis McCarthy in the first place, and many others. And there are many more friends which I cannot mention here. Let me say a few words about the Campaign Oversight Committee. It was planned in 1989 at the Edinburgh Scientific Assembly of the IHE. Basic plans were made by Nader, Melbourne, Minster, and Nealon. This planning committee was reorganized and renamed as IGS Campaign Oversight Committee at the 20th IOGG General Assembly in Vienna, where I became then the chairperson or chairman of this club. Ironically, when traveling to Vienna, I took a holy oath not to accept any further obligations from IAG. And you see how things work. And I ended up as the chairman of the IGS. Okay, nobody thought that it would become such a big thing. But anyway. The work of the IGS Oversight Committee, it organized the IGS test campaign in 1992. This test campaign started on the beginning of summer 1992, and it ended on the 23rd of September. That's the end of summer 1992. I think it was probably one of the most, or even the most important decision for the IGS not to interrupt tracking and analysis on September 23, but to continue operations on a best effort basis after the test campaign. What I would also like to mention is the last item in the frame, the first IGS workshop in Bern, where when we were the terms of reference for the final IGS were drafted here in Bern. Actually, in my office, with iron breathing down my neck. So it was a special experience. Now I press the wrong button probably. I always liked that's the IGS tracking network as it looked in 1992 and today. I always liked this map on the left-hand side. It's somehow very clear and undoubtedly global. Bruce Nealon showed that at many occasions, and I also grasped this transparency. The network is much larger today. It has more than 500 receivers. More than 300 of them are multi-GNSS. And I don't like the picture as much as that, although it's colored, because it looks like the Earth with measles. Okay. The first decade of the IGS service, as already mentioned, it became an official IAG service on January 1, 1994, and I happened to be the founding chair. In October 1998, we had an experiment called IGS, a 3-month GLONASS test campaign. In 1998, I was already put out of power, and Chris Wright followed me. Chris Wright, who is also sitting here as a chairperson. In March 2000, I would like to mention this because it was a very good experience. So we had a tutorial in South Africa, and I would recommend that for future use. In 2001, the GLONASS service pilot project started. These two events, the IGEX and the IGEX, they are really due to, I would say, Jim Slater. You see his picture here to the left, who was pushing very hard for the IGS to process not only GPS data, but also GLONASS data. And you see Rose Nealon's picture. I think it is very important to mention here that she had very many talents. So the most striking for me was when we were in 1993, I think, in Beijing, that's in China, just for those who don't know, when she was giving an address in Chinese. I don't know which version of the Chinese, but not only I was surprised there, but also the Chinese people. Okay, and yeah, we are already at the bottom of this page. There was a 10-year IGS analysis workshop here in Bern again, and it was also a very good experience. In the IGS, we were not only observing GNSS satellites, but also analyzing the data. And not only one institution did that, but first a handful of institutions. Today, I think there are 10 such institutions doing that. And we thought that it would be somehow important to have not 5 or 10 individual products, but one official product. And these people, which you see here, Jan Koba and Tim Springer and myself, which you see here, they were generating the first software to do that. And when we tried to convince the IGS governing board to go for that, they finally accepted that, and I still remember what Jan Koba said when this exception happened. Oh, Gerhard, they really bought that. Yeah, which was not so clear. And you see here the learning curve of the IGS. This is in essence, you see the consistency with respect to the combined orbit as a function of time. To the left, we have the year 1994. To the right, last Friday, I think, when I fell off my bike, but that's not connected to that. What you see here is a consistency of analysis center contributions to the IGS combined final orbit. And it is today of the order of 1 centimeter. In 1994, it was of the order of 25 centimeters. So the learning curve is really rather spectacular, I think. By the end of the 20th century, it became clear that the IGS is not only a GPS service, but it's of importance for a much broader basis of users. And this was written down in a report where again you see 1, 2, 3, 4, 5, the 6 authors, 4 of the 6 authors present here in the audience or as a speaker. And you can correlate the pictures you see with the appearance in the audience, and you see almost no changes. Second decade of the IGS started really with an important step, the renaming to the International GNSS Service. Then, in green here, first green line, first reprocessing campaign, 1994 to 2008. Very important, these reprocessing campaigns, because they use the same constants, algorithms, etc. In January 2011, Urs Rubentrop became the successor of John Dow, who pointed out that he actually is the only chairperson staying for 8 instead of 4 years. What is clear from if you do the calculations yourself, it escaped my attention here. Yeah, then in 2011, the IGS call for participation for the multi-GNSS experiment was launched. Multi-GNSS really meaning here analyzing the data of more than 2 GNSSs. In 2013 and 14, we already have the second IGS reprocessing campaigns, and 2014 the IGS workshop and celebration of 20 years of service in Pasadena. It's the predecessor of this meeting here. I have one slide concerning multi-GNSS. As I already mentioned, it was initiated in 1998 by the GLONASS 3 months campaign, continued in IGLOS. Both were initiated by Jim Slater or organized by him. Then the coordination was passed on to the GNSS working group chaired by Robert Weber. From 2012 onwards, the IGS multi-GNSS working group took care of the multi-GNSS experimentations with Oliver Montenbroek as chair. You probably know that he is in the audience. I think we owe him a lot. The true value of the IGS network with its list of 500 sites, well documented, receivers well documented, it allows you to analyze the GNSS performance of a global tracking network. This site list allowed it, for instance, to analyze the GLONASS April 1st choke incident in 2014. I'm not going through that right here, but it's still documented in the internet. In hindsight, the development of the IGS was a fantastic experience, certainly for me personally. There were many firsts, but for me the most amazing was the willingness of the international geodetic community to join forces around 1990 for science. That was remarkable in particular because there was no dedicated funding allocated to this club. I think that's still the case today. The challenges are quite different today. The IGS provides not undisputed, well-established and indispensable contributions to the ITRF, the International Terrestrial Reference Frame, to LEO orbit determination. But it also indirectly contributes to the ICRF, the International Celestial Reference Frame, and the establishment of the Earth's gravity field. Such contributions ask for an observational basis spanning the decades to centuries. My plea would still be to reach the 60 years of the ILS. I don't like it that the ILS has a longer lifetime than IGS. I will conclude with an example of the IGS as an interdisciplinary service. On the left-hand side, we see the mean total electron content in the Earth's ionosphere from high-resolution ionosphere models, which are in turn based on at least dual-band phase observations gathered by the IGS sites. You should ask Stefan Scher for more details if you wish. And we see that we are scanning through 3 periods of solar maximum activity. To the right, you see a time-resolved polar motion picture, which shows, now I'll see whether I understand this thing. Yes. To the bottom, everything started quite normal. We see the superposition here of the annual and the 14 months period. And something strange happened here. No? So, up here. I would say essentially in the years 2015 to 2020, where the polar motion radius became very small. I have one more slide about that, and then I'm all done. Here. If you analyze this curve on the left-hand side, and say, well, there is an annual signal and the 14-month signal, then you get the curves. The blue curve is the annual signal in the time when the IGS observed. So here, from something like 200 plus milliarc seconds, the radius dropped to close to 0 at 20, 30 milliarc seconds. And whereas the annual amplitude still remained on 100 milliarc seconds. 100 milliarc seconds, by the way, is something like 3 meters on the surface of the Earth, so it's not really much. To the right, we have the picture of Chandler, says Carl Chandler, who claimed polar motion to consist of 2 constituents with periods of 14 months and 1 year. That's undisputed, and it was accepted right away. In 1901, he also claimed that the 14-month signal actually consists of two constituents of similar in size, separated in period by only a few days, which leads to a very long peak period. And probably what we see here, in around 2018.3 is the latest of these minimum of the channel period. So, this brings me to the epilogue. Very nice name. I contacted watered many friends and colleagues when preparing this overview to check my memories. I thank all of them. You can go through the list yourself. I would like to mention the last name, Richard Langley, who was reviewing my first scientific papers and now has the honor to have reviewed my last presumably last scientific paper. So that's all I wanted to say.